I'm Ryan Neary, and I worked with Jake Petrino to show our classmates how to evaluate area between two curves. And the main principle between evaluating area between two curves is if you are evaluating the area in regards to x, you are going to want to take the top line and subtract it from the bottom line, and then take the integral of that, which would look like, in this case, f of x minus g of x, and then dx. And that would give you the area of this right here. And it's from 0 to 4 because here you could see the lines are going from 0 to 4. In another case, you are going to have to evaluate in regards with y. So this comes with lines that are more vertical, so that the y-axis is what's changing more than the x-axis. So the only difference when you're integrating with respect to y is you subtract the right line minus the left line, and then take the integral of that. Just make sure you have the right annotations with the dy and dx. Other than that, there is no other important secret you should know. So let's get into it.
Here's an example finding the area between curves with respect to the x-axis. So the first thing you're going to want to do is when you get your equations, you're going to want to graph them out. So for this one, we have y equals negative x squared plus 3, which is that parabola facing down, and then x squared plus 1. And then what you're going to want to do when you have these graphed is find the points of intersection. So in this case, it is going to be x equals negative 2 and x equals 1. And then you're using that for the limits of your integration. So let's go ahead and set that up. And then what you want to do from here is you're going to take the equation of the top function minus the equation of the bottom function. So set that up. So it's negative x squared plus 3. And then minus x plus 1 dx, because we're integrating with respect to x. Alright, so then the next step, just simplify that a little bit, make it a little cleaner. And then we get negative x squared minus x plus 2 dx. And then when we integrate that, we're going to get negative 1/3 x cubed, so that's just adding 1 to the exponent and then dividing by whatever that number is. So then we get negative 1/3 x cubed minus 1/2 x squared plus 2x. And then what you're going to want to do from there is you're going to want to evaluate that at the limits that we originally got. So that evaluated from negative 2 and 1. And then you're going to subtract those. Okay, so then when we do that, it comes out to negative 1/3 minus 1/2 plus 2. So that's when we evaluate it at 1. And then when we evaluate it at negative 2, we get 8/3 minus 2 minus 4. And then when you finally simplify all that out, you're going to get 9/2.
Find the area of the regions enclosed by the curves. Some good steps to follow when solving a problem like this is to sketch a graph, find the points of intersection, and then in this case, integrate with respect to y to find the areas. The reason we're integrating with respect to y is if you look at the graph, the blue line is vertical and the red line is a sideways parabola, which in this case, the distance between the y-axis, that's what's changing more than the distance between the x-axis. So it's easier to integrate with respect to y when you are solving for the area. Now, in order to solve the area, you need the points of intersection, and this you might not be able to graph by yourself since the two equations are kind of complicated, but if you plug it into your calculator, you get that, and the points of intersection come out to be 5.25 comma 5 and 3 negative 4. Now, to solve this, you're going to want to take the integral of the right line minus the left line. So the way that looks is you would take the integral from, in this case, negative 4 to 5. The reason for that is since we're integrating with respect to y, the two y coordinates in the points of intersection, you're going to use those as the limits of integration because that's where the y-axis is changing in this equation. So you use negative 4 to 5. Then the equation would be 1/4 y plus 4 minus 1/4 y squared minus 1. And then you would do dy instead of dx. Then that would equal negative 1/4 y squared plus 1/4 y plus 5 dy. That's just subtracting those two equations together. And then you want to use the anti-power rule because this is where you're going to want to take the integral of it. So the squiggly line is going to go away. You're going to get, using the anti-power rule, which is adding 1 to the exponent and then multiplying the fraction by whatever that number turns out to be. So in this case, it would be 1/12 y cubed, because if you look here, that would turn into 3, and then you would multiply this number by 3. All right. So that turns out to be that. Plus 1/8 y squared, because this, the 1/4 y would just add 1 to the exponent, which makes it squared, and then you multiply the denominator by 2, which makes it 1/8, plus 5y, since you're just adding a y there. And then you would evaluate that at from negative 4 to 5. And when you plug those numbers in and subtract, you get 425 over 24 minus negative 38 over 3, which if you plug that into your calculator, you get 30.375. And that's how you integrate with respect to y.